Okay, so we've noticed the pattern when we've been differentiating using first principles, and we just know by sight that the derivative of 2x is just going to be 2. We just know it, don't we? I hope we do anyway. Okay, we also know the pattern here that 2 is going to come down the front. And then the 2 is going to become a 1. So the derivative of x squared is just going to be 2x. The derivative of x cubed, the 3 is going to come down the front, and then the 3 in the power is going to become a 2. It's going to become 1 less. We'll do that again. Now the 4 is going to come down and join that 5. 5 fours are 20. And the power 4 is going to reduce by 1 to get 3. There's just a power. You can see how I've been trying to change the terminology as well. We're reading this as differentiate with respect to x this function. That equal sign shouldn't be there. It should just be the derivative with respect to x of 2x equals 2. That's my bad, sorry about that. This one here, if y equals x squared, determine y dash. Y dash is the gradient function, it's the derivative function. So y dash equals 2x. Here, it's the same thing. The gradient function can also be called dy dx equals 3x squared. So it can be y dash equals, it can be dy dx equals, it could also be f dash x equals, it could be slope equals, it could be gradient equals, and they all equal this gradient function. Okay, find the gradient function of here. So this is just a parabola, isn't it? We need to work out what function tells us the gradient of this parabola. Well, that's our gradient function, which is, let's just go with the easiest one, y dash, 6x minus 2. And the 1 disappears. We know that, don't we? Yes, we do. Well, we do now. Okay, find the gradient of this function where x equals 1. So to find the slope where x equals 1, first of all, I need a gradient function, y dash. So that will be 3x, 6x squared plus 8x minus 2. And that 1 drops off. That's my gradient function, and I want to find the gradient where x is 1. So I just set x equal 1, and my slope of that cubic where x equals 1 will be 6, and 8 is 14, will be 12. Determine where on this function the slope is 2. So I need a gradient function. So y dash is the slope, which is going to be 4x plus 0, because that 10 will disappear. So I've got y dash equals 4x, and I've written the word slope there as well, because that's the gradient function, it's the slope, and I want the slope equal to 2. So I'm going to make that equal to 2 and work out where x needs to be to have a slope of 2. Well, that's x equals a half. What that means is that if I graph this function, and we can all graph that quite easily because it's a nice, happy function about the y-axis, and I'm going to say where x is a half, this thing is actually quite steep. And we're happy with that because that 2 tells me that it's a steep parabola. That's justifying the reasonableness of my answer. Okay, we've been using the rule. What is the rule? That's what you'd write on your exam if you needed to state the rule, and you'll have something like that in your formula sheet, I am sure. This is how it works. So the derivative with respect to x of 3x to the 5. So there's my a, there's my x, and there's my n. We're going to get the n and the a together. So the n goes down to join the a to become 15. Then the power reduces by 1. So instead of being a 5, it becomes a 4. Yes, it's a really easy pattern. It's a really easy rule. Go do some practice.